now that we have discussed the different scheduling strategies we have for batch and interactive systems, we can go back for a moment at the differences between user-level threads and kernel-level threads and how they are related to scheduling. And hopefully now this should be clear. So we said last time in the previous lecture that we have user-level threads, and kernel-level threads. If we use user-level threads, then a set of threads are managed in the user space, but they are all linked together with the same kernel thread. Okay, so from the perspective of the operating system, the kernel is picking a process. Okay, it could be process A or process B. Within the process, then there can be several user-level threads. Okay, and these are scheduled by in user space by the process itself. Okay. On the other hand, if we have kernel-level threads, then the kernel is actually picking a thread of a specific process. So it can run, let's say, thread 1 here, then it can go to thread 2 here, and then it can go back to thread 3 here. So these 3 threads, they can belong to different processes. While here, you would probably change between thread 1, 2, and 3, while the operating system is just running this process. As we said, if you use user-level threads, and one of them, for example, issues a request through a system call to the operating system, the entire process will go into waiting. So all the threads, not just the one that is asking for some input-output, will stop executing because of a blocking code. This does not happen with kernel threads. So if we look at the pros and cons, so you see that now user-level threads are actually extremely good when you want to have fast context switch, because actually you can change the thread that is executing with no real context switch. You don't need to involve the operating system to do the context switch. So you save a lot of time. The time it takes to go from one quantum of execution to another one and change the thread, it's basically nothing, because everything happens inside the process without involving the operating system. And you can define your own scheduler. So if you don't like the scheduler that you have in your operating system to run a set of processes that are CPU bound, you can use user-level threads and then write your own scheduler with your own policy to run your processes. But the negative side, as we said, is that if one thread blocks because of input-output, the entire process blocks. So all the user threads. If you look at kernel level, or if you use kernel level threads, then it will cost more to do the context switch, so you pay an overhead, but you can have threads of a multi-threaded process that are still executing, even if some of them are into some input output and they need to wait before they get access to the CPU again.